The main topic of Chapter 7 is trigonometric identities. What is a trigonometric identity? It's a statement that relates trig ratios. So it's an equation. You have one trig ratios on one side of the equation, trig ratios on the other side of the equation, and it's always true for all values of the variable. So we have already learnt some of these, like the reciprocal identities. You know that the definition of cosecant theta, it's equal to 1 over sine theta. They're always equal to each other, no matter what angle you put in. And secant is 1 over cos. And cotangent theta is 1 over tan theta. So I'd like you to write above these, you could also change sine theta to be 1 over cosecant theta. And cos theta to be 1 over secant theta. And tan theta to be 1 over cotangent theta. Because these are always true for all angles, they're called trig identities. Some other trig identities from our big idea. You know that tan of theta is sine theta over cos theta. That's always true. Pick an angle, 22 degrees. Tan of 22 degrees. Enter it in your calculator, push enter. Then check sine of 22 degrees divided by cos of 22 degrees. It'll be identical. And cotangent of theta is cos theta over sine theta. Okay? And if you look at all of them, you can always change any trig function to a sine theta or cos theta or a combination of them. Pick one. You pick cotangent, you can change cotangent to cos theta over sine theta. Right? Pick tangent, it's sine theta over cos theta. Pick secant, it's 1 over cos theta. Pick cosecant, it's 1 over sine theta. So if you wanted to, if you have an equation with a lot of different trig functions, you can always reduce it to just sine theta and cos theta if you want to. That's going to come up as a major strategy for proving identities, which is what we're going to be looking at today. These are our initial toolbox. Okay? I'm going to add one more item to our toolbox, but these are the initial things that you already know. Okay? With these, if you do one mental math thing to them, for example, can you see that I could multiply both sides of this equation by sine of theta and then get cosecant of theta times sine of theta is equal to 1. And I could do the same thing with secant of theta and cotangent of theta. You're allowed to do one mental math thing in your head. So if you saw cosecant theta times sine theta and you wanted to, you could change it to 1 right away by skipping a step. Some people, though, are going to do this instead. Change something first to sine and cos, and then see what kind of math you need to do. So let's find some space for you guys. Do you still have room at the top of page 606? Okay, write this at the top of page 606, proving identities. So we're going to get a question that looks like this. Prove secant theta divided by cosecant theta is equal to tan of theta. So the first thing that you're going to do when you get a proof question like this is you're going to rewrite what you want to prove, which is secant theta cosecant theta equals tan of theta, and where the equal sign is, draw a line. You're trying to prove that they're equal. If you ever do math on both sides of the equation, like you know how if you can divide both sides by 5, you do that? That only works if you have an equation that's true. Does that make sense? And so anytime that you work on both sides of the equation in a proof, it's an automatic 1-mark deduction because you're trying to prove that they're equal, so you can't use that they're equal to prove that they're equal. Otherwise it's like, I assume that they're equal, oh, therefore they're equal. That's not a mathematical proof. So our job is to draw the line, and then it becomes a puzzle. Can you manipulate both sides to make them the same? And one of the main strategies that we're going to use at the beginning is what we wrote over here. You can always change any trig function to either sine theta and or cos theta. So when I look at my equation here on the left side, what could I change secant to? I could change it to 1 over cos theta. And what could I change cosecant to? 1 over sine. So here's my main division line. I'm going to make that one longer. So cosecant theta is 1 over sine theta. And what can I change tan theta to? I can change it to sine theta over cos theta. So once we've changed everything to sine theta and cos theta, this is where that fraction work at the beginning comes into play. Can we simplify the fractions on both sides so we get a single fraction? On the left side, you see that you have a fraction divided by a fraction. But on the right side, I have a single fraction. The right side is simplified. But the left side, I'm dividing a fraction by a fraction. What's the rule for dividing a fraction by a fraction? You don't need to show anything for that. Anything that's in here is your toolbox. You're allowed to use any of those ones. And as we go through this unit, we add some more to our toolbox, some more proofs that you're allowed to use, or some more identities that you're allowed to use. So far, you're allowed to use this one. I'm going to show you one more after we're done this question. Okay? But now I have a fraction divided by a fraction, so I'm going to show my work. That's the same as multiplying by the reciprocal. So I write the reciprocal. How do I multiply fractions? Multiply my numerators, multiply my denominators. And so 1 times sine is sine theta. 1 times cos is cos theta. And we have completed the puzzle. We wanted to manipulate both sides to make them identical. That's what a proof, a trig proof, looks like. Now, once you've done that, there's some other formalities that we need to do to finish. Okay? To finish our proof, we need to write a statement. These 3 dots mean therefore. Okay? Have you seen that before? Therefore, left side equals the right side. We have showed what we want. So we write therefore the left side equals the right side. Then we add some fancy Latin QED. Lots of math proofs end with QED. QED is short for Latin. Anybody know? Yeah, no. I'm going to butcher the Latin, but here we go. Quod erat demonstratum, maybe, somewhat. And what that means is what was asked for has been demonstrated. You asked me to prove it, and this is where you feel like it's kind of fun to write because you're like all proud about, yeah, I did it. I accomplished what I want. So QED, what was asked for, I showed it. If you'd rather write that whole sentence out in English, you can. I think you might prefer to write QED. Okay? And then I always end my proofs with a little symbol. My little symbols, I draw a little box, and I shade the bottom a little bit. It's just you feel good to, you can make your own symbol up if you like. You can put a check mark in yours, yeah, put a little box, check it off, like, yes, got it, okay?
Do you have to write that, like the
Yes, you have to. Yeah. You can make your own little symbol. In one of the textbooks that I took in university, all the math proofs had a little box at the end, so I got used to doing that. You'll notice in a lot of magazines, when they finish their article, different magazines have a little symbol to end when their article is done. It's just, I think Maclean's has a little maple leaf with an M in it. Probably for magazines, you're reading a magazine and you're like, have you ever read an article in a magazine lately? You start on page 3, you end on page 15, and you have 105 ads in between. It's like, magazines are all advertisements and stuff. So you're like, when does this article end? So often they put a little symbol to like, oh, I've actually finished reading this, even though you only read like a paragraph per page. Okay? So I add a little symbol at the end. You can make up your own little symbol, or if you want to do the box as well. But yes, you need to make a statement that you have finished your proof. Yes. Okay? Oh yeah, you could also write what has been asked for has been demonstrated, the full sentence. If you would like to write that out, that's fine. Because it's nice. It's formality. Feels good. Okay. It's like, now, the other thing in your toolbox is another of your big ideas from chapter 6. You know that sine squared plus cos squared is equal to 1. No, this is just another thing in your toolbox. You know this already. Okay? So any single mental math thing that you do with this, for example, does it make sense that if I got sine squared by itself, it would equal 1 minus cos squared? So if you ever get a proof that has a 1 minus cos squared theta in it, you could change it to sine squared theta. And if you ever had a proof that just had 1 minus sine squared theta, you could change it to cos squared theta.